Again, good afternoon, everyone. So this is the continuation of the topic. We'll be going to the mirrors. Still, I'm setting up for the mirrors. Wait, I'll be sharing my screen in a while. Okay, right? It's in here. I'll be sharing my screen.
Not yet.
Okay, can you
There,
see
there.
now my shared screen?
Yes, sir.
Yes.
There.
Right. So again, we were talking yesterday or the last day about the law of reflection, right? If lenses bends light, reflection now or the mirrors bounces light. Okay, there are some certain angle of incidence being used in mirrors is always equal to the angle leaving the surface or the angle of reflection. Okay, question so far with the law of reflection and the angle of incidence. Rate 10.
And
Okay,
and so far.
light itself is invisible until it bounces off something and hits in our eyes, just like when you see colors. Okay, colors, it bounces a particular beam that hits our eyes, and we can consider that a particular color. During birth or at birth, we cannot actually identify the different names of the color, but you can see already colors. For instance, a beam of light traveling through space and can be seen from the side until it runs into something that scatters it, like a cloud of hydrogen or a satellite. This scattering is known as diffuse reflection. Again, the scattering of light that hits our eyes is called diffuse reflection. And this is how our eyes interpret what happens when light hits an uneven surface. Again, the term there is diffuse reflection. The law of reflection still applies, but instead of hitting one smooth surface, light is hitting many microscopic surfaces. It's more like throwing a handful of marbles against a statue and then guessing the statue's shape based on how the marbles is being bounced or bounces. Mirrors, however, don't scatter light in this way. Within a smooth surface, light reflects without disturbing the incoming image. This is called specular reflection. Again, with a smooth surface, light reflects without disturbing. If it is reflects without disturbing the image, the incoming image, this is called specular reflection. Okay, that concept raises the interesting question: if mirrors preserve the image that hit them, why they turn left into the right and vice versa? Why not up and down? Okay, so the question there is, if imo daw ilihok ang item or an object going to the right, it will go against left. Again, if you will move an object going to the right, the object will move going to the left. Have you tried using microscope? This is highly observable in microscopes. Like if you have letter E in your microscope, it will go upside down. And if you will, uh, kung nagatubang ka sa letter E sa microscope, no? If you're going to look at it in your naked eye, because you can see that one in your naked eye, and you're going to use that one under the microscope, it will actually looks upside down. Okay? If you're going to move the slide going to your right, in the microscope, it is actually moving towards your left. What do you think is the reason behind? Or if you're going to look at the ambulance, the word ambulance in the ambulance car, you can see it uh, written backwards, right? But if you're going to look at it inside the car, it is incorrect spelling or written correctly. What do you think is the reason so? Yes, Biloso?
Uh, the ambulance signage in the ambulance is written backwards so that people inside the car can be alerted that that vehicle at the back of them or on the side of them is an ambulance, because their side mirrors are reflect an inverted image.
Why is that so? Let's answer that question. Okay. The truth is that the mirror doesn't really reverse left or right. What mirrors switch in front and back like a printing press of a rubber stamp? Imagine writing something on the sheet of paper in dark pen and holding it in the mirror. It looks backward, but it also looks the same as if you held it up to the lamp and looked at it from behind. Your mirror image is a light print, okay? Not a reflection of you from the mirror's perspective. Actually, it was not actually changed, okay? Your ambulance written that way simply because, yes, correct, Beloso, for us to be notified that it is an ambulance, okay? But uh, it was actually written backwards in order for us to view it correctly. The mirrors itself didn't actually change it. It is our brain that changes it. Again, it is how our brain interpret the stimulus. Are you familiar with the stimulus? Stimulus response? Stimulus. Anything that causes us to move, or anything that causes us some reaction. Okay, that's a stimulus. Now, considering an image, if you're going to look at an image, your brain but your brain actually thinks or analyzes that image. Okay, talking about reflection, some of the mirrors reflect backwards because our brain interprets it backwards. But the mirror itself didn't actually change it. It is the perspective of our eyes. Okay? Just like when you put a pen, okay, try this at home. You put water on the glass, okay, clear glass, and put a pen on it. Okay? When you put the pen there, tendency is you're seeing the pen moving on the opposite side. Okay? That is because of the refraction. Okay? The water itself didn't actually change it. Okay? It is our eyes that actually see, or the see, it is our eyes that actually see the bending of those image. But the image itself actually didn't change. It is called what? Visual illusions. These are visual illusions. Okay? There are a lot of visual illusions that you can find at home, even in scientific galleries. Okay, you're thinking that the lines are moving, but they are not. It is our brain that interprets it. Let's move forward. Any questions so far? Grade
No
10?
so far.
All right. Mirrors can be more than just a flat surfaces. Next up, we'll be looking at some imaginative ways to use mirrors. Okay, let's move now to virtual image. Okay, what is a virtual image, by the way? The type of image produced by a flat mirror is called a virtual image. Even though the light is bouncing off the mirror, our eyes are fooled into thinking it's coming out from the mirror. Okay, in a straight line, the virtual image can't be focused. But some mirrors, like concave mirrors, can produce a real image, which can be projected into a surface, just like your projectors. The quick way to change the way mirror works is to curve it. Curve mirrors, again, let's move backwards with the virtual image. The virtual image, it means that you're looking at a flat mirror. just like your mirrors at home. It creates actually a virtual image. You are thinking that the image came from the mirror, but it is actually a reflection virtually. Question so far with a virtual image? Question?
Yes, sir.
Okay. One way to quick change the way a mirror works is to curve it. Curved mirrors come from two basic types of concave and convex. Same with your lens. Okay? Convex mirrors, which bulges outwards, reflects at a wider angle near its edges than the center, creating a slightly distorted image that is smaller than the actual size. Convex mirrors have many uses. Now, smaller size images means that you can see more than with these surfaces. Hence, the use of mirrors as safety. This is why passengers in the mirror, side mirrors, that object are closer than they appear. This is actually mirrors used in your side mirrors, the cars. So if you're going to look at it, you can actually see that it is actually near or closer than they appear. Some department stores have reportedly placed convex mirrors in their dressing rooms. Why? Slight bend at the top of at the top and bottom make you look taller and thinner. Okay. Some also convex mirrors are used in the grocery. No? Have you seen this one? The big mirror, convex mirror.
Yeah. The
So that
corners.
yes, it will actually gather more images because it is wider to look at. It can actually gather more wide. It is wider than the usual mirror. That's our perspective. Question with convex. Let's move now to concave or converging mirrors. These are curved inward like spoon. No? The side that holds the soap. This gives these mirrors the ability to create an image when their curvature bounces light to a specific area in front of them. This area is called the focal point. Again, if you're talking about concave lenses or concave mirrors, it has a focal point at the center. From from the far away, the object will seem upside down, but as you get closer in the focal point and pass to the focal point, the image flips and magnifies. Concave mirrors are used everything in everywhere, from shaving mirrors to lighting the Olympic torch. There are some unusual types of mirrors. The non-reversing mirrors. Patents for non-reversing mirrors go back as far as 1887 when John Derby created one placing mirror perpendicular to each other. Just like you're placing different mirrors in the same mirror. Have you seen this one? You are now actually you are at the center of two mirrors. That's a non-reversing mirror. Right? This is actually an experiment or done by John Derby during his time. The acoustic mirrors. Acoustic mirrors are huge concrete dishes built to reflect and distribute sound instead of light. Okay? It is actually used in before in recording studios. Now I've seen this one. The English military used them before the invention of radar as early warning system against air attacks. We also use this one. I actually seen this one in recording studios. Why do you have acoustic mirrors here? Or I do have mirrors here. This is to reflect or distribute the sound instead of light. Two-way mirrors. This is one of the interesting mirrors. Why? These mirrors are made up of coating one side of a sheet of a glass with a very thin, very lightly reflective material. When the coated side faces the lighted room, some of the light reflects and some goes into the dark room behind the mirror, making it possible to see into the lighted room but not out. Have you seen this one?
Yeah, in some buildings.
Some buildings uses this one, correct? No? It is actually a mirror, but you cannot see it through because the mirror reflects your image. But behind behind the mirror, they can actually see you. Those are two-way mirrors. Okay. Again, interrogation during the scene of the police show that they are using a two-way mirror. Okay. Interrogation with the suspect, for example, and the police. Okay. There's a mirror there. That is a two-way mirror because they are actually also observing you or observing uh, the interrogation. Let's
How
talk
did they
about
do that, teacher?
um well, two-way mirrors has two sheets of glasses. Okay, the first glass is coated with a reflective material, no, lightly reflective material, and the second glass is for us to see them. Okay, there's no coating in the second material. That is why you can actually see them, but they cannot actually see you. Okay, because these mirrors reflects an image or a reflection to the other side. But in the other on the behind that mirror is a transparent material. That is why. Okay. Question so far?
None so far.
Okay. I think that we all that is our lesson about mirrors and lenses. I'll be checking your activity. I'll be ending this shared screen. Let me check on your activity. Okay, activity 1. You're all 10 students? Online students?
Um,
12.
12?
Nina,
oh,
Stephanie.
So some of you didn't actually do the activity?
some are offline, teacher, but are not sure with the others.
Okay, okay. So since we still have time, I will open again the activity and I want others to perform their activity or else you will not have your I cannot give you grade.
Excuse me, sir. This
It's the
the
activity
activity,
7.
the lens.
Mirrors and
Is that
lenses.
mirror?
Okay, I'm done
Okay.
with that.
Thank you.
I'll open it again for 1 hour. We still have 11:34 here in my time. I'll open it 11:34 to 12:34. Okay, done. Well, I think that will be all for today. Expect for activities in the future. We have a lot of I prepared a lot of activities for the topic. What's the difference between real and virtual? Okay, real. Real is without the use of mirrors. Okay, real. The one we are actually seeing. Okay, face to face. That's reality. That's real images created by our eyes, our optic nerves. Virtual images are created virtually. When you say virtual, it is not real. Virtual. Created by your mirrors. A reflection. Just like your mirrors at home. It creates a virtual image. Any other question so far? Questions in your mind, at the back of your mind, before I end the Zoom meeting? What else? Question below, so Audrey, Inario?
And so far.
Okay. Hopefully you learned something out of our simple discussion, and I think that we all, for mirrors and lenses, active.
Teacher, Trisha has another question.
Yes, yes, Audrey, go.
Trisha has a question.
The flat mirrors are virtual image. Virtual image. Again, flat mirrors creates a virtual image. kanay mo nakita sa mirror nga image, it is not actually came from the mirror. It is called virtual. Okay? Another question? Another question? Question so far?
None.
Are all questions being served?
Yes.
Okay. I think that will be all for today, class. Expect for, again, some activities. And thank you for your cooperation. Thank you for participating in the class. I think that will do for today. Have a nice day, everyone. Goodbye.
Likewise. Bye.
Thank you,
Thank
sir.
you.
Bye.
All right.